Okay, Assalamualaikum and good morning. So today we will proceed point estimates and confidence intervals in chapter 5. Okay, a point estimate is a single statistic used to estimate a population parameter. So we use statistics to estimate population parameter. Okay, for example, the sample mean X is a point estimate of the population mean. Okay, so we use sample to estimate population. Okay. Okay. So while we expect the point estimate to be close to the population parameter, so we would like to measure how close it is really is. So we use confidence interval to see how close they are between sample and population. Okay, confidence interval is a range of values constructed from the sample data, so the parameter occurs within that range at a specific probability. So actually for confidence interval, that adalah range of value. Okay, so actually this one we will calculate the value, and then the specific probability is called the level of confidence. Okay, basically researchers select different samples randomly from the same population and then compute a confidence interval for each sample to see how it may represent the true value of the population variable. Okay, so basically at the end of our result should be 95% confidence contain the true mean of the population, for example lah. Okay, so later we will see how to find the confidence interval. Okay, for reasonably large samples, the result of the central unit theorem allow us to state the following. So 95% of the sample means selected from the population will be within 1.96 standard deviation of the population mean. Okay, or 99% of the sample means selected from a population will be within 2.58 standard deviation of the population mean. Okay, so actually this one 1.96 and also 2.58 is the value of Z. Okay, so later we will see how we get this value. Okay, from the next slide. Okay, the standard deviation discussed here is the standard deviation of the sampling distribution of the sample mean. It is usually called standard error. Okay, intervals computed in the above mentioned manner are called the 95% confidence interval and also 99% confidence interval. Okay, so this is the example how we get the value of Z. Okay, so we know that the distribution is 100% or the area under the curve is 1. So from this part, okay, so they kata 95% confidence interval. Okay, so this one is 95% or 0.95 probability. Okay, and then you need to find 100 minus 95%, so you will get 5%. 5% is between these two tails. Okay, balance between two tails. Okay, if you consider one tail, one tail only, so you need to divide. Okay, 0.05 divided by 2, so you get 0.025. 0.025 is the probability for the left tail and also right tail. Okay, if you total up these two tails, so you will get 5%. Actually same. Okay, now if you refer table 0 to Z table, okay, actually for 0 to Z table, the probability is between these two lah. Okay, you need to find this probability. Okay, and then you will know the Z value. Okay, so same thing you need to do is, okay, we know that half of the curve, the probability is 0.5. So 0.5 minus 0.025. So you get 0.475. 0.475 is indeed probability. Okay, now you need to find Z value. Okay, so actually from the previous chapter, we know that Z value and then we want to find the probability. Okay, from this part, you know the probability, so now you need to find the Z value. Okay, so please destroy table. Okay, the value gets close to 0.475. Okay, so you get the value is 1.96. 1.96 is our Z value. Okay, so that's why if 95% confidence interval, our Z value is 1.96. Okay, and then if you write in the formula, confidence interval formula, so you get the answer like this lah. X bar plus minus 1.96 times S divided by Zn. Okay, then goes to the 99%. Okay, this one minus 99, so we get 1%. So 1% is include these two tails. Okay, so if you want to see one tail only, the probability, so you need to divide by 2, so you get the value is 0.05. Okay, this is the probability for the left tail. Okay, and also for the right tail. Okay, if you total up these two tails, so you akan dapat 0.01 probability. So actually it's same. Okay, now same goes to the this previous example. So you need to find the probability here. So 0.5 minus 0.005, so we get 0.4950. Okay, now what is the value of Z? Okay, so 0.4950, actually this one is close to the 0.4950. So our Z value is 2.58. Okay, so that's why if 99% confidence interval, our Z value is 2.58. Okay, and once you can memorize this confidence interval, or you can find your Z value based on confidence interval. Either one lah. Okay, if you want to find the Z value based on confidence interval, you can do the calculation like this. Okay, and then if you want to memorize, okay, you can memorize this table. Okay, so for example, 85% confidence interval, so our Z value is 1.44. Okay, so this one is for Z only. Okay. In general, a confidence interval for the population mean is computed as X bar plus minus ZS divided by Zn. So X bar is our sample mean, and then Z is Z value corresponding to the level of confidence. So actually Z value depends on level of confidence. So for each level of confidence has a different Z value. Okay, and then S is standard error or standard deviation, and then N is sample size greater than 30. Okay, so if our N is greater and equal to 30, so you can use Z table, Z distribution. But if your N is less than 30, okay, so you need to use another distribution. Okay, you cannot use Z distribution. So later we will see what happens if our N is less than 30. Okay, so now for Z distribution, your sample size should be N greater and equal to 30.